Hello and welcome back to Code for Teachers. This is Chapter 3, Section 2, Lists. We're ready to jump into the first iterable data type that we're going to learn about, and these are lists. Lists are sequences of other data types. Now, what's important to know about lists in Python is that they can contain any other data types, including other lists. Now, there are other iterable data types that you might hear about, sets or tuples, but we're going to focus on lists for right now as our basic sequence because it's most of what you end up using in your Python code. Now, lists are iterable just like the strings that we saw in our intro. They can also be sliced, meaning that we can create sublists or permutations of lists using special commands. Lists also have built-in methods to allow us to operate on them, like append and pop, which we'll see in a little bit. This is what a list looks like and when we attach it to a variable. So we can say things equals, and then inside of square brackets, the elements that we want in our list. So this, we're initializing our variable things to be the list containing the integers 4, 5, 6, and 7. Now, in this example, all of the elements of the list are of the same data type. They're all integers. But it doesn't have to be that way. In this second list stuff, I have an integer, a floating point number, a string, and a Boolean value. Lists in Python do not care about the data type. Now, we said before that lists are indexed, and what that means is that every element in a list has a specific address, which begins in 0. In computer science, we start counting at 0, and every element of a list has an index, which we will use to directly access that element. So let's consider this list here, the list X, that has all of the letters that make up Python. But if you'll notice, we have done a list of strings. So each of these letters is a separate string, separated by commas. All right. So if I wanted to get a specific letter out, I would need to know its position in the list. When I explain this to students, I often talk about indices as addresses on a street. We start from 0 and we go down the row. And the syntax for accessing a specific value is the name of the list, square brackets, and then the index that you want, and that will return the specific value that you want. We can also make slices of lists. Now, this is a bit involved, and we'll show examples for each of these, but slices are really important in working with lists. It allows us to take a single list and make different versions of it. Using those same square brackets, we can create these permutations, while also, as we saw, accessing specific indices. So it goes like this. If we say for our list, and we do square brackets and then I, we'll get the element at index I. We can also say if E is in list, and what that will do is it will return true if the element E is in the list and false otherwise. And here come our slicing methods. If we say list I colon n, it'll produce a sublist that starts at index I up to but not including index n. So if I started list 0 colon 4, it'll give me the first 4 elements, but not the 5th, which would be index 4. I can also use this slicing syntax to create a copy of a list, which may be useful later. So I would just leave both sides of that colon blank to create an exact copy of the list that is stored separately from the original. There's another extension to slicing that gives us a step or interval value. So this INS version here with the 2 colons will produce a sublist starting at index I up to n in intervals of size s. And it's easiest to think of this as skip counting. We'll show you these in just a second here. It's also important to remember that when you're doing this skip counting, the interval can be negative. Okay, let's take a look at just this much so far inside of our coding environment. So I've started things off with just a sample list here. It's kind of like a grocery list. Things equals and then strings, milk, bread, eggs, apples, and juice. I'm not going to do any other code on the left-hand side for the moment. I'm just going to hit run, loading this list into memory. So let's say I wanted to retrieve just eggs from the list. I could do that saying things and then bracket 2, because if I'm counting 0, 1, 2. Let's see if I can get the last element of the list. Things. And like I said, our values can be negative, so let's try -1. That produces the last element of the list pretty effectively. Let's try to make a sublist that goes up to apples but excludes juice using our slicing syntax. So we'll do things 0, colon 3, sorry, colon 4, because it's up to but not including that fourth index. So that produces milk, bread, eggs, and apples, but excludes juice. Now let's try to do things but skip count. So we'll get every other. So to do this, we will leave empty colons, but then have an interval of 2 at the very end. So that skipped bread and apples. I also had that ability to check to see whether a specific value was inside of a list. So let's try that. I can say milk in things, and that should return true. If I try something like fish in things, that'll return false because fish isn't on our list. So let's add it. In addition to the slicing, we also have 2 list methods that I want us to be familiar with. The first is append, which is how we add things to the end of lists after they've been created. And the other one is pop, which will change the list. It will remove the last item and return it as a value. You can also give pop a specific index and remove an item at that specific index. Let's go back to our coding environment and check that out. So let's try to append fish here. So we'll do things.append and then the string fish. If I ask for things now, at least loaded up in memory, I now have fish. Of course, that doesn't change my code on the left-hand side, but while the program is running, now things has fish. I'm going to clear my screen here just for a little bit of extra screen space. Let's bring things back up on the board. All right, so we've seen append. Let's try pop. And let's say I want to remove eggs. So 0, 1, 2, that's index 2. So I'll do things.pop 2. That returns eggs. So if I needed that value assigned to something, I could assign it that way. But remember that pop is mutative. So if I ask for things again, eggs is gone. I can add eggs, of course, back onto my list with the append method. But it won't be in the same place. It'll be now at the end of the list. Okay, with those basics covered, let's move on and try a name reverser. So what we're going to do here is we're going to take a name and return it reversed. We can do this pretty easily, of course, because strings are lists. Okay, so what do we want to do here? Well, we want to first get the name. So we know how to do that. We're going to do name equals input. What's your name? Or any other question you want to use as a prompt. And we're going to print its reverse. Well, let's think about how we might reverse something using the methods we know. So let's think about how we could maybe do this. We know that we can do slicing, and we know that we can have negative values. So you could imagine that perhaps if we did something like this, where we take the full value of the list, we don't slice it at all, but we give it an interval of -1, what we end up doing is we walk backwards through the list, or the iterable. And that works just fine. So in fact, this is pretty simple. What we're going to do is we're going to print name and then use those square brackets, colon, colon, -1. Just to make sure we're clear on what we're doing here with the syntax, we're going to print the value of name. We want a string, so we don't have to do any conversion here, but we want the entirety of the list, or the iterable, so no value before the first colon, no value after the first colon, and then for our interval, we're going to go -1, meaning that we walk backwards through the string. Let's run this and see what happens. And it works. Okay, that's it for this video. In the next one, we're going to talk a little bit about dictionaries, which are iterables as well, but they have a little bit more structure than the list that we've been using so far. I'm Michael Taggart. Thanks for watching Code for Teachers.